Right now, somewhere over the open ocean, a weather pattern is forming that meteorologists did not expect to see for weeks. Not days, weeks. And yet, here it is, spinning into shape right in front of satellite cameras, months ahead of schedule. If the current models are even close to correct, this could become one of the most talked about weather events of the year. Stay with me, because by the end of this video, you will understand exactly why forecasters are suddenly glued to their screens and why this pattern is moving faster than almost anyone predicted. To understand why this is such a big deal, you first need to understand how these patterns usually behave. Most large-scale weather systems build slowly, warm water evaporates, moist air rises, pressure drops just a little, and over the course of many days, sometimes weeks, that small disturbance organizes itself into something bigger. It is a gradual process, almost lazy, like a snowball rolling down a very gentle hill. Meteorologists rely on that slow buildup to give communities time to prepare, track the system, and issue warnings well in advance. But this time, something is different. Instead of the usual slow buildup, this system skipped several stages almost entirely. What should have taken 10 to 14 days happened in less than 5. Forecasters who study these patterns for a living are calling the speed unusual, and a few have even used the word alarming in early briefings. When a system compresses its development timeline this dramatically, it becomes much harder to predict exactly where it will go and how strong it will ultimately become. So what is actually driving this rapid setup? A combination of factors is lining up almost perfectly, and unfortunately for forecasters, perfectly in this case means perfectly for rapid growth. Ocean temperatures in the region are running noticeably warmer than the seasonal average, giving the system an unusually rich source of energy right from the start. Warmer water means more evaporation, more moisture pumped into the lower atmosphere, and more fuel available for the pattern to feed on as it develops. On top of that warm water, upper-level wind conditions are behaving in a way that actually helps the system rather than tearing it apart. Normally, strong wind, shear high in the atmosphere, disrupts a developing pattern, ripping the structure apart before it can fully organize. Right now, that shear is unusually weak across the exact region where this system is forming. It is almost like every obstacle that would normally slow this pattern down has been removed at the same time, clearing a wide open lane for it to intensify. Meteorologists have a term for this kind of rapid strengthening, and it is a term that tends to make headlines whenever it shows up in a forecast discussion. They call it rapid intensification, and it describes exactly what it sounds like, a system gaining strength far faster than typical models expect. Rapid intensification events are notoriously difficult to forecast because the atmosphere does not always give clear warning signs before the acceleration begins, which is part of why this current setup has caught so many experts off guard. Historical comparisons are already circulating among weather researchers, and some of them are genuinely striking. A few of the systems being referenced as comparison points went on to become some of the most damaging and closely studied weather events in recent memory. To be clear, that does not automatically mean this new pattern will follow the same path. But it does explain why so many experienced forecasters are choosing their words carefully instead of dismissing the early signs. One of the most interesting parts of this story is how the major forecasting models are reacting. In the early stages, computer models often disagree with each other, showing wildly different possible paths and strengths for a developing system. What is unusual here is that several major models, ones that typically diverge in these early days, are actually starting to agree with each other much sooner than expected. When independent forecasting systems begin converging early, meteorologists tend to trust the trend line more, and that trend line is currently pointing toward continued strengthening. Naturally, this raises the question everyone watching wants answered. Which regions could actually be affected if this pattern continues on its current path? At this stage, it is still too early to give a precise, guaranteed track, and any forecaster who claims certainty this far out should probably not be fully trusted. What we can say is that certain coastal zones are already being flagged as areas of interest by regional weather agencies, and residents in those areas are being encouraged to start paying closer attention to updates over the coming days. It is worth pausing here to explain why early forecasting is genuinely difficult, even with today's advanced technology. Weather models rely on massive amounts of real-time data, ocean temperatures, air pressure readings, wind patterns at multiple altitudes, and humidity levels across huge stretches of open water where direct measurements are limited. Small early errors in that data can multiply as the model projects further into the future, which is exactly why forecasts tend to become more accurate and more confident as a system gets closer to any populated area. If you are new here, this channel is called Universe Proof, and this is exactly the kind of story we love digging into, big natural patterns that most people do not notice until they are already unfolding. We break down the science in a way that actually makes sense, without drowning you in technical jargon you did not ask for. If that sounds like your kind of content, sticking around for the rest of this video is a great place to start. Let's talk about the atmospheric ingredients a little more closely, because understanding them helps explain why this situation feels different from a typical seasonal pattern. Beyond warm ocean water and weak wind shear, there is also unusually high humidity sitting in the mid-levels of the atmosphere across this region. That moisture acts almost like dry wood thrown onto a fire that already has plenty of fuel and plenty of oxygen. Instead of the system stalling out or weakening as it pulls in drier air, it keeps finding exactly what it needs to keep building. Another factor experts are watching closely is the surrounding pressure pattern. A stable area of high pressure nearby is effectively acting like a wall, steering the developing system and limiting its interaction with drier, more stable air masses that would normally slow its growth. Combined with the warm water and low shear, this steering pattern is essentially giving the system a clear, protected lane to keep developing without the usual disruptions that break these patterns apart early. It is important to mention that not every rapid setup ends in a historic event. Sometimes these systems intensify quickly and then just as quickly hit a wall, running into dry air, cooler water, or disruptive wind shear that forecasters could not have predicted days earlier. Weather remains one of the most complex systems scientists study, and even with satellites, ocean buoys, and supercomputers running constant simulations, there is always a margin of uncertainty that keeps meteorologists humble. That said, the agencies responsible for tracking this pattern are not waiting around to see what happens. Additional reconnaissance flights and specialized monitoring tools are already being positioned to gather real-time data directly from the system as it continues developing. This kind of direct data collection is critical because it feeds straight into the forecasting models, helping refine predictions and catch any sudden changes in strength or direction much faster than satellite imagery alone ever could. For people living in regions that could potentially be affected, the advice from experts right now is simple and consistent. This is not the moment to panic, but it is absolutely the moment to start paying attention. Reviewing emergency plans, checking supply kits, and staying tuned to official updates over the next several days is a smart move, regardless of how this particular system ultimately develops. Being prepared early costs very little, while being caught off guard can cost a great deal. There's also a bigger picture worth mentioning here, because this event does not exist in isolation. Researchers who study long-term weather trends have been noting an increase in these rapid intensification cases over recent years, tied in part to warming ocean temperatures across multiple regions worldwide. Whether or not this specific pattern becomes historically significant, it fits into a broader trend that scientists are actively studying, trying to understand how rapid strengthening events might become more common going forward. As this story continues developing, forecasters will be updating their models multiple times a day, and honestly, that is part of what makes this so fascinating to follow in real time. You are essentially watching scientific prediction happen live. Models adjusting, agreement forming, uncertainty narrowing, all playing out over the course of just a few days instead of weeks. Few natural events give us this kind of front row seat to how forecasting actually works under pressure. We will absolutely be tracking this pattern as new data comes in, and if the situation continues escalating the way current models suggest, there will likely be a follow-up video breaking down exactly what happened and why. Weather stories like this one are exactly why staying subscribed matters, because these situations can shift dramatically within just 24 to 48 hours, and you do not want to miss the moment things change. Before you go, I want to ask you something directly. Do you think this pattern is going to intensify further, or do you think it eventually loses steam like so many early setups end up doing? Drop your prediction in the comments below. I genuinely read through them, and it is always interesting to see how many of you end up calling it correctly before the official updates even come out. If this video helped you understand what is happening and why it matters, do us a favor and share it with someone who would find this just as fascinating. It genuinely helps this channel grow, and it helps more people understand the science behind these patterns instead of just seeing scary headlines without any real explanation behind them. Thank you for watching all the way to the end. Make sure you are subscribed so you do not miss the next update on this developing pattern, because based on everything we are seeing right now, this story is far from finished, and the next few days could end up being the most important part of the entire event.